Alright, hey everybody, this is Andy Johnson coming back at you with Mojotone. We finished up our board build. This is the actual video of showing you the two other auxiliary boards. One, of course, is your filter cap board, and the other one here is your bias supply board that the Deluxe Reverb had. Also the twin reverb, super reverb, the 6L6 fixed bias amps had this board in them. And again, if you notice, there's no holes drilled in these. And I will get to that here shortly, but I just wanted to show you the simplicity of what these boards are, as compared to what we just finished here. This is our spiny lobster we have going on here, AB763 full main board, ready to drop in. Of course, we'll also need our backer board here, the insulator board that Fender used for the, actually, a good, I'll say 99% of their amps up until about 78 or so. And again, these don't have holes in them, and I will show you here shortly where to put those holes. And I will have your filter cap board here, which isn't shown on the wiring diagram, but it is shown on the schematic. And we do have a downloadable PDF picture of how the actual cap board looks, how it's laid out. Very simple. You have your main supply here, your B plus main supply, then you have your second and third stage filtering here. Of course, with the voltage dropping resistors in between each stage, and it actually shows you on the bottom, tells you where these actually go, which it'll also actually tell you on the schematic as well. If you're well versed with schematics, it's not a problem, you won't even need this. But not only do we give you this so you can see how the actual board is laid out, we actually give you this so you can actually see on the schematic where these caps are and how they are in relation, with the power supply going through the schematic. Because again, schematic is signal flow and power distribution, as well as your grounds, whereas your wiring diagram is more or less a GPS map of the overall layout of the actual circuit itself. So I'm going to solder our leads and our jumpers. Of course, we have jumpers, as you can see here, across the actual filter caps. Your main section here having two caps that are running parallel, and the rest of them are actually running series with dropping resistors, like I said before. So this is the basis of the actual filtering section of the Deluxe Reverb, and this is pretty common. Of course, back the original AA and AB763s, all of them, which included again the Super Reverb, Twin Reverb, Deluxe Reverb, Pro Reverb. The caps that were in those were much larger. They would actually span almost the entire width of this board, and this board is a stock size board. It's actually what came in the AB763s, but through really cool engineering and advances in electronics, we can now make the same cap with a voltage rating half the size of what it actually was, because they're much more efficient now, and they do maintain a super high level of quality control when with these particular caps. These are King caps that we have made for us, and we were very involved in the manufacturing and development of these caps, and we're really happy with them. And we also have some new ones coming out that we're having made, can caps and such for a lot of the Marshall stuff, and the Princeton Reverb takes a can cap. So we're really proud of that, and that should be out in the next couple months, which is a superior quality King cap, or not a King cap, but an actual filter cap. Multi-section can caps like F&Ts and JJs make. We just like to raise the bar a little bit as far as quality goes with that stuff. But okay. Anyway, I'll get back to this real quick. Bias supply board, filter cap board. I'm going to pause this for now. I'm going to add our leads to it, and this will be populated, and I'll show you how this actually goes into the actual chassis and what is going on. Okay, so just hang in there. Okay, so we're back. I've got the bias supply board made here. Of course, I'm notorious for having super extra long leads, and I need to trim the back of this real quick. Now, on the wiring diagram that we send, it's historically accurate in regards to how Fender routed their wiring and stuff. But one thing I like to do, and I think I mentioned this maybe a couple videos ago or some of my other videos, that I like to leave things as transparent as possible. So if I can get away with having jumpers on top of the board to ease the serviceability down the road, I'm all for it. And this jumper wire right here actually was it's under the board in the original Fenders, and that we actually have the same way. It should be under the board on here, but I like to have this here just so I can glance at it and know it's there and not have to worry about testing it down the road in case something happens or goes wrong. Now, one peculiar thing about bias supply boards is that, or bias supplies rather, is that you need to remember that it's applying a negative voltage. So I get a lot of questions about people that have never done fixed bias amps like this, or Marshalls, or the bigger Fenders like Twins and Bandmaster Reverbs and Showmans and things like that. They say, well, the cap's in backwards. Well, no, it's not, because the diode is actually making an inverse voltage in reference to the actual chassis itself. So the voltage that you're going to see on the back end of this is going to be a negative voltage applied to the bias supply. I'm not going to go too much in depth with that. We go a little bit more in depth with our classes that we give, but this is how it's supposed to look, really. Of course, nothing underneath again, and I'm leaving this eyelet here not soldered because our bias supply from the actual transformer, our 54 or 55 volt bias supply voltage, will come in here. And actually, if you notice, the diode, the ring on the diode, corresponds with what's on the actual diagram, a line, and this is your dropping your resistor here. And anyway, read up on bias supplies. It's kind of interesting how you can induce a negative voltage, into the actual circuit itself. Again, that's our bias supply board, and this big one here is our filter cap board. Oops, let me turn this around here. And again, I'm using really long leads because I love wire. I have miles of this in my shop. So here we have our first, second, third stage filtering for the actual Deluxe Reverb, and this serves, of course, all the circuits in the actual amp itself. It steps down the voltage as you go down the board. Now, Fender used, I've seen metal oxide, and I've seen metal film, and I've seen different types of resistors used in the power supply for dropping. I've actually seen these as big old, I think they were 2-watt carbon cops, I guess they used at one time for this, but we like to use a metal oxide, much more efficient. They dissipate heat a lot easier, and they can take surges a lot, current handling a lot better than what a carbon comp or carbon film can do, which again is their color. You'll see these in blue, green, and gray, actually. So and I try to I like to color code some things sometimes, just because you won't be able to see this once the cap pan is on the actual base of the chassis itself. If you get the cap pan on, if you're servicing down the road, you can actually tell which wire is going to which. Where if you had these all yellow, you would need to do a continuity check to make sure that you had the right section feeding the right voltage to the right part of the amp. And using multicolor leads like this kind of gets rid of any of the guessing that you have. Okay. One other thing about filter supply boards, notice there's no jumpers behind, they're all on top, is that there's a reason, and I mentioned this with the 5E3 before. Of course, it doesn't have a cap board, but there's a reason that they segregated the grounding from the preamp to the output section and the actual power supply. And they did this here. Now, a lot of people get lazy and they'll just bridge all these across to one ground. But what can happen, and the reason they do this, is because you can actually, any of the hum that is filtered out of the first section, out of your main B plus power supply, if it's filtered out, it can actually be induced back into the circuit further down the chassis if you don't segregate these grounds. So any hum that's reduced here or taken out of the out of the mix here, I guess you would say, and the actual power supply, again, would be could be potentially through ground, could be potentially induced back into the preamp. And you don't want that because, again, especially if you're feeding, you have your grounds here, and these two stages actually, they share a ground. What would be happening is that even if you're only blocking 10% of the hum, or you're not using a ground, or something happens in your amp, all the hum that is induced back into the chassis itself will manifest itself back into this section, and of course this feeds our preamp, which will actually be amplified back at the first gain stage of the amp and amplified all the way down, the circuit itself. Any resistance you can put between grounds, especially in your power supply, is good. The more resistance you have between the grounds, like if this was all the way on the left-hand side of the chassis, this is all the way on the right-hand side of the chassis, that's the best case scenario. The more resistance you have, this segregates the two circuits, the better off you have. It makes the hum or any type of noise that's being induced or trying to be filtered out in the first section, it totally segregates that. The more resistance you have between the two, the quieter the amp is going to be. So that's why they did this. And you'll also notice on the wiring diagrams as well, and I think I mentioned this in the 5E3 as well, when we're looking at this, there's a reason, these are your grounds right here, these little arrows. And there's a reason that they didn't have all these going back to one particular area, because they wanted to keep the ground short. And again, the flow of the actual circuit itself starts at the preamp and works its way down. Now the voltage is reversed. The voltage is started down here. Your B plus is here. Of course, your B plus goes down to your filter cap board, and the second and third stages are induced back into the circuit here, as well as here. And that feeds your plate supply for your preamps. So there was a reason that these grounds were done the way they were done. I'm not a big proponent of star grounding, especially with Fender amps, because I have yet to actually see somebody pull this off to where it's any better than segregating your grounds and having the shortest grounds possible that you can. From what I've seen, a lot of customers, they'll build these kits and they like to do star grounding because that's something that they learned, on a forum or something like that. You can possibly pull that off on a Marshall pretty well, and Vox circuits as well. But with Fenders, it's a tough thing to pull off. And every one I've seen, and heard of people doing star grounding, where all your grounds, especially your preamp grounds, any of your signal grounds in your tone stack, your reverb and tremolo grounds, back to one point, which is usually down by the power supply, is not a good thing. You can you'll start having some really weird things you can't explain, like oscillations. The wiring in here even gets more fickle to where if you put a plate near a grid wire, it starts going haywire. Whereas if you have the ground segregated here, it actually it doesn't promote that happening. It kind of cancels it. I won't say it cancels itself out because it's not a humbugging configuration, but it keeps things where they should be. Your preamp is on the right hand side. You draw a line right down the center of this preamp power section minus your tremolo here. So yeah, there's a reason that they did that, and it's good to follow this. Of course, when you start, when you get into these and you start doing it seriously, you will realize that there's certain things you can and cannot do with the grounds. With your wiring for the reverb, sometimes it's advantageous to have, go ahead and have shielded wire to your inputs and some of your tremolo and or reverb wires, because you can pick up a lot of noise. But again, those are little things that you just learn as you go along. But again, there's a reason that the grounds were where they were here in these circuits. Okay, so at this point, what I'm going to do is, because I've got our cap boards done and I've got our main over here, we have our main board done here. Next thing I'm going to do is drill holes in the chassis, or not in the chassis. The holes are already in the chassis. I'm going to drill holes in the board. Okay, now let me get this little thing out of here. I don't have any fingernails. Where are my pliers at? I'll use these. I get all these little wire pieces out of here. There we go. Now, when we're looking at the chassis, there's two holes for mounting the actual board itself, And I like to do this after the board's assembled because, I mean, at this point I could do it before the board's even assembled, but I just like to show that, you know, once you get your board populated and it's like, oh crap, I forgot to put the holes in there. Well, you know, it's kind of better you do that. You know, wait till the end. Reason being is that, you know, when you see a hole here, you need to make sure that when you pass the hole through the actual fiberboard that you're not intruding on another wire here, that you could be potentially clamping it down with the screw, you know, and shorting that actual wire out. And it happens a lot. It sounds like a really, you know, simple thing, but it happens a lot, and people don't really think of that. They'll set the board down, drill right through the board, not thinking about it. You nick your insulation on the back, you put your screw through it, and all of a sudden that, you know, your plate supply here for your preamps is grounded. You keep blowing fuses. You got weird voltages. You can't figure out why, and you know, a lot of times it's something as simple as that. So anyway, what I like to do is I'll lay the actual board in here and get the, if you want to look at this in sections, I guess it would be kind of the vertical, you know, section. This, of course, is horizontal, but looking, you know, front to back. Line the holes up to where here, I know that's good, so I know that's going to be good there. And these holes, let's see here, these holes should come out approximately in this area here, in the first preamp, and down here before the actual phase inverter section of the board itself. There's two screws that hold it in place. So if I can get it in there, and I know about where, let's see here, right there and right there, what I can do is I can push down on this, and I also want to make note of where my filter cap board mount screws are, or excuse me, the actual filter cap pan screws are. Sorry, mosquito in here. You want to make sure you clear those, and you want to make sure that you're not covering up the you know, your grommets completely here. Of course, they're going to be about halfway covered, but that's okay because the wiring, you know, you don't have that many wires coming through. All right, so I'm going to hold this in place, and I'm going to go underneath and use my pencil, the most valuable tool I have in here, and I'm going to mark here and here. I'm not sure if I got that or not. Where's that? No, I didn't mark that, but I did get this one. All right. So this is going to be right about here. All right. So, and yes, a pencil will show up on this fiberboard. So I've got this hole here. Is there a file here? All right, I'm going to put this off to the side, and then I'm going to mark, while the chassis is in this orientation, I'm going to go ahead and mark out my bi-supply board, which there's two holes already drilled in the chassis for that. All right. So that's here and here, and I'll make sure I'm not too far over. I'll be here. And what I'm going to do, actually, to make things simpler so I can do everything from the top side, is just mark the top side, and then I'm going to drill it. And once I get a screw in this one place, then I'll be able to reference the other hole for the actual bi-supply board. Alright, and next will be our filter cap board, which goes underneath a good majority of the Blackface amps. They have a doghouse, what people call doghouse, or a cat pan that covers all of this up. Now, when this goes in, actually let me spin the chassis around real quick. Alright, so we're looking at it normally. Okay, so the grounds on the filter cap supply, or filter cap board rather, always go towards the control panel itself. And what I mean by that is that if you look at this drawing, this arrow here is your ground, one of your grounds. Now this ground over here, this is your reverb driver. And I like to have, let's see here, and this is your ground here. So you have two main grounds coming off your filter cap board, ground for filter cap board. This is your main, your first supply, that's your B plus, is down by your power supply. And you know this arrow here is pointing towards this way, and I like to ground this usually on a bus bar somewhere around the normal channel pot ground bus that I'll be adding later on. You'll see that, and it facilitates the grounding of the cathodes a lot easier too. So, but these are your two main grounds here. Okay. All right. Now, put the cap board in place, and again, your grounds will go towards the controls itself. And I'm looking at this, and with a good majority of the actual cap boards that we have for the Blackface, we do drill hole. We do not have holes drilled in this, because we have a lot of builders that will use this chassis and or this cap board, and they said they don't want the holes in the stock place, leave them off, we'll drill them ourselves, because there's certain things, they might have a different filter supply that they're using, and the holes would be different, so you'd have to re-drill the holes either in the board or the chassis. So that's why we don't do that. Okay, so what I like to do is, if you notice the mount holes for the actual doghouse itself, the cap pan, I am going to, let's see here, center this, and this is critical now, because I'm just looking at the board. I'm just looking at my grommets to make sure I have everything even, and that the board will actually in fact be inside the cap pan. Alright, so I'll do two holes. I'll do one here, and I'll do one down here. Alright, then I will drill our board, drill our chassis, get this mounted in, drill our main board, mount that in, and then our bi-supply board, I'll get that drilled and mount this in. And I will be back shortly. Alright everybody, I'm back. I've got our three boards in place so you can see what they look like. Bi-supply board here, main board here, and our filter cap board underneath. Sorry. And that's how it should look. So you got wires going everywhere. There are wires all over the place on this thing. Alright. Now, a note about mounting the boards, and I'll be real brief about this. We include, I believe it's the number 8 self-tapping screws that Fender originally used. They're stainless. They go directly through the board into the chassis itself, and you do not need to use a nut. The same thing with the filter cap board underneath. And with this, with the bi-supply board, Fender used, I've seen 440s here, I've seen those self-tapping screws, and I've also seen 632 screws through here, but I just use 440 here because they're small, unobtrusive. So, alright, so this is the final installment of actually mounting our boards into the chassis itself, and you see I got 8 miles of wiring here we're going to go through. But this is how you want it to look. Alright, it's organized chaos. Everything's in place. There's nothing falling out. Yep. Alright, we're good there. Okay. So, our next video, we're going to start wiring this beast up. We're going to have ourselves a reverb amp on our hands here pretty shortly. So, stay tuned, and thank you everybody so much for watching these videos. Taking time out of your life to, spend time looking at this stuff. It is great. I can't, thank you enough for everybody, especially the way the world is today. It's absolutely crazy out there. I hope we don't run into any more of this, and I hope it doesn't last much longer. But everybody, please stay safe. Lock yourself in a house, or your room, or your apartment, or your condo, or whatever you have. Lock yourself in there and build yourself an amp, and you'll come out stronger on the backside. I tell you, man. All right, thank you guys, and I will be back with you shortly. Take care.